Hello student, welcome to digital classes. This video is for class 8 science. This video is for class 8 science chapter number 11. This video is the first part of force and pressure. Force is the push or pull on the object. Example, if an object has to be moved, it has to be pushed or pulled. In other words, a push or pull acting on a body which tends to change its state of rest or motion is called force. Force is usually denoted by letter F. In this picture you see one man is pushing car from the back and two girls are pushing each other. Force arises due to the intersection between at least two objects. Force are due to the intersection of two or more bodies. An intersection of one object on another object result in a force between the two bodies. For example, if a man standing behind a car, the car does not move. If he pushes the car, he applies the force and the car begins to move in the direction of the applied force. You see in this picture, two boy pushes the box from one side, and then in the second picture the boys are pushes opposite to each other. Now exploring force. If two force act on a body in same direction, then net force is the sum of the two forces. Means net force is equal to F1 plus F2. If two forces are act on the body in opposite direction, then net force is the difference between the two forces. Net force is equal to F2 minus F1. The effect on the object depend on the net force acting on it. Now the effect of force on an object. Force can make an object to move from rest. Force can stop a moving object. Force can change the speed of an object if it is moving. Force can change the direction of a motion of an object. Force can change the shape of an object. Force may cause one or more of these effects. Now, type of forces. There are two main type of forces. One is contact force and second is non-contact force. Contact force are force exerted by one object on another when they are in contact with each other. Contact force are of two types. They are muscular force and force of friction. Non-contact force are forces exerted by one object on another without any contact with each other. Non-contact force are the three types. They are magnetic force, electrostatic force and gravitational force. Now the contact force, muscular force. Muscular force is the force exerted by the muscles of our body. We use muscular force for our various activities. Animal like bullocks, horses, camel, donkey, elephants also use muscular force to perform various tasks. Now the force of friction. Force of friction is the force which opposes the motion of an object over a surface. For example, a ball rolling on ground gradually slows down and comes to rest due to the force of friction. If we stop paddling a bicycle, it generally slows down and comes to the stop due to the force of friction. Now non-contact force, magnetic force. Magnetic force is the force exerted by the magnet. For example, force of attraction and repulsion between two magnets. Force exerted by the magnet on a piece of iron or steel. We know that magnet exists in poles. There is two poles, south pole and north pole. If we brought close to the two magnet with a like pole, it repel each other, and unlike pole, it attract towards each other. Now the second non-contact force, electrostatic force. Electrostatic force is the force exerted by a charged body on the uncharged body or another charged body. For example, a plastic straw charged by rubbing with paper attracts a suspended plastic straw. A plastic straw charged by rubbing with paper repels a suspended plastic charged by rubbing with paper. Now, third non contact force is gravitational force. Gravitational force is the force exerted by the earth on all objects. It pulls all objects towards the earth. For example, a coin or a pen fall down when it slips off your hand. A ball thrown upward falls down. Leaves and fruits fall from the ground and when they are detached from the plant. And water in rivers flow downward. Now I can explain about force little bit more. Force has both magnitude and direction. Means force is a vector quantity. In higher classes you will be able to understand about the vector quantity. Force applied on an object in the same direction added to the another. If the two forces act on an opposite direction on an object, the net acting on it is the difference between the two forces. In general, more than one forces may be acting on an object at any given point. However, a force acting on an object is always the mean net force acting on it. Now let us discuss about unit of force. Various type of force are described below. SI unit. The SI unit of force is Newton. The unit Newton is denoted by the letter N, capital letter N. Some other unit used for describing force are kilogram force. The force required to lift a body of mass 1 kg vertically is called 1 kilogram force. The unit kilogram force is denoted by kgf in small letters. Gram force. The force required to lift a body of mass 1 gram vertically is called 1 gram force. The unit gram force is denoted by GF. From the kilogram relationship, we can write 1 kgf is equal to 1000 gf. It has been denoted experimentally that 1 kilogram force is equal to 9.8 Newton or 1 kgf is equal to 9.8 Newton. For the sake of convenience is calculated solving numerically. Generally 1 kgf is similar to 10 Newton. Now the resultant force. In many situations, more than one force act on a body at the same time. All these forces collectively produce the same effect in the body as if a single force is acting on the body. Such a single force is called resultant force. The resultant force may be defined as the single force which act on a body to produce the same effect in it as done by the force collectively is called the resultant force. Now see in a picture, when two forces act along the same line in the same direction, let us consider a cart pushing by Syam with the force of 100 Newton. He could move it very slowly. Arun offered his help. He applies a force of 150 Newton in the same direction. Together, both the friends were able to move the cart faster. This is because when two forces act in the same direction along the same line, the resultant force is equal to the sum of two forces. Here, resultant force on the cart is equal to 100 Newton plus 150 Newton, that is 250 Newton. As a result of the greater force acting on a cart, it moves faster. When the two forces act along the same line but in the opposite direction. Now let us consider the cart pushing by Syam with a force of 250 Newton. He could move it faster quite easily. Now Arun start pushing the cart with a force of 150 Newton in the opposite direction. Now Syam could not move it, only slowly. This is because when the two forces acting along the same line but in the opposite direction, the resultant force is equal to the difference of two forces. Here the resultant force acting on the cart is equal to 250 Newton minus 150 Newton, that is 100 Newton. So a force can be larger or smaller than the other. The strength of the force is usually expressed by its magnitude. The resultant force being smaller, the cart could move slowly. If an object is acted upon by two equal forces along the same line but in opposite direction, the resultant force acting on the object is zero and the object does not move. Now I will take one example to understand good. The force applied by the member of two team A and B in a game of tug of war and mention against each other of them. Calculate the resultant force and name the winning team. All the members of A team apply force in the same direction. Therefore, the resultant force of the team A is equal to 450 Newton. The resultant force of the team B is equal to 225 Newton, 225 Newton. Now the net resultant force is equal to 450 minus 225 Newton, that is 225 Newton. Since team A is applied a net resultant force of 225 Newton, so team A would be the winner. Now I explain some question with true or false. If an object is at rest, no force are acting upon it. The answer is false. There are many forces acting on it, like gravity, friction, or air pressure, etc. But they are all balanced. Now the next question is, when there is a force, there is a motion. Is it true or false? Answer is false. Force may be present but it does not necessarily result to motion. If forces are balanced, no motion will be produced. Now the next question. In the absence of force, object will continue to move constantly. Is it true or false? The answer is true because force will slow down or stop the motion. Now let us understand balanced and unbalanced force. Force occur in pair and they can be either balanced or unbalanced. Now balanced force. Balanced force do not cause change in the motion. They are equal in size and opposite in direction. In other words, when the resultant of all the forces acting on a body is zero, the forces are said to be balanced force. The balanced forces cannot set any stationary body into motion, cannot change the speed or velocity of the moving body, may change the shape or size of a soft object. Balance force. The force on the book are balanced. The table pushes upward on the book. Gravity pulls downward on the book, but the resultant force is zero. So there is a balanced force. We call this normal force. The book is said to be at the equilibrium since there are no unbalanced force acting upon the book, and it maintains its state of motion. It still sits on the table or the book is at rest. Now see another example of balanced force. The force on the person are balanced. Let us say you are standing on a ground since the floor pushes upward on you and gravity is pulling down on you. You are at equilibrium means you are at rest. So the force is balanced. Now unbalanced force. An unbalanced force always causes a change in motion. When unbalanced force act in opposite direction, you can find the net force. Net force magnitude, the difference between the two forces direction of the largest force, means when the resultant of all forces acting on a body is not zero, the force are unbalanced force. Let us consider the game of a tug of war. When the force exerted by two teams are equal, the force are balanced and then rope does not move. But if the total force applied by the team A is greater than that applied by the team B, then the rope as well as the member of the team B will pull towards the team A due to the unbalanced force. It means the unbalanced force can set a stationary object in motion, set a moving object at rest, change the direction of the motion. See the unbalanced force. One person which is on the right apply 3 Newton force and another person on the left applies 6 Newton. So the resultant force is 3 Newton minus 6 Newton, which is equal to 3 Newton left. In the second example, the orange one apply 4 Newton force and the green one applied 10 Newton force, that is in the right side, and the orange one in the left side. So the net resultant force is 4 Newton minus 10 Newton is equal to 6 Newton right. See, there is two, one is boy and a woman. Boy apply 5 Newton right and woman apply 10 Newton right, which is equal to 15 Newton right. This is also an unbalanced force. So now you understand what is force. Force is a vector quantity. It has magnitude as well as direction. Now let us discuss some example of balanced force also. Forces are balanced if they are the same strength but in opposite direction. See, for the boat, this is balanced force. Upthrust of water and weight of boat. Weight is due to gravity. Both are equal, means the resultant force is 0. So the ship is in the balanced force. Now see in this figure, the 100 Newton force is applied from the back and 16 Newton from the front. So what is the resultant force? Now let us discuss little bit more about force and their effects. You cannot see a force, but you can see what it does. You can also feel the effect of force on your body. What can a force do? A force can make an object moving. I already told about this in the previously. A force can make a moving object stop. A force can change the speed of a moving object. A force can accelerate an object. The larger the force on the object, the greater the acceleration if the mass stays constant. The larger mass of the object, the smaller acceleration if the force stay constant. When we apply the external force, the body get accelerated. Force can change the direction of a moving object. In rugby, when bowler throw a ball, and the batsmen hit the ball with their baseball bat, which means they change the direction of the ball. Force can change the shape of an object. You see in a picture, the lemon is squeezed by a person to change its shape. I think everyone understand about the force, and I will discuss pressure in the next video.